My answer is, how can you not be interested in physics? I mean, we're only talking about the universe. We're only talking about the fundamental laws that drive the entire universe. So for me, it's hard to understand how people are not fascinated by stars and galaxies and black holes, how people cannot be fascinated by the way the universe is put together.
Imagine waking up to the chilling news that a mysterious object from beyond the stars is hurtling towards us at over 7,000 miles per hour. But it's not just any space rock. It's breaking all the rules of science. On July 1st, 2025, astronomers detected 3I Atlas, an interstellar visitor with a chemical makeup so bizarre, it's forcing scientists to question everything.
I first became interested in physics when I was 8 years old. I still remember that all the newspapers were stating that a great scientist had just died, but on his desk was the unfinished manuscript of his greatest theory. Well, I was fascinated. What could possibly be so fantastic that a great scientist could not finish that book?
This isn't fiction. It's happening right now. The truth behind 3I Atlas could change the way we understand our place in the universe. Are we alone? Or is something far more terrifying out there? Unlike anything seen before, 3I Atlas's movement through our solar system was the third such recorded instance of an interstellar object visiting us. It was only the third confirmed object to come from outside the solar system, the first being the mysterious Oumuamua, which passed through in 2017, and the second, Boris, a comet detected in 2019. The speed at which 3I Atlas was traveling, over 137,000 miles per hour, was enough to confirm its origin beyond our solar system. Its rapid movement ensured that the sun's gravity couldn't capture it, confirming that it would not be sticking around, but instead would race through the solar system and continue its journey into interstellar space. This discovery was met with an urgent scramble by scientists around the world to gather data. Telescopes across the globe, from Hawaii to South Africa, focused their lenses on the object, and the data they gathered confirmed that this was no ordinary comet or asteroid. The path it was taking had a hyperbolic shape, meaning that it wasn't bound by the sun's gravitational field. It was simply passing through, never to return. This was an unprecedented moment. For centuries, astronomers have studied objects from within our solar system, but this object, 3I Atlas, was something else entirely. It was not from our system, and it had just entered our cosmic neighborhood. The object's discovery became a topic of great interest within the scientific community, and it also ignited public intrigue. This event showed the world that our solar system, long thought of as a contained, closed system, is far from that. Objects, dust, and debris from beyond the stars can, in fact, make their way through our space, and it was not just a fluke, but a rare occurrence. Yet this rare opportunity brought with it a sense of urgency, as astronomers knew this would be the only time to study the object before it raced away, never to return. And as the global astronomical community scrambled to gather data on 3I Atlas, one name began to emerge repeatedly: Michio Kaku. Kaku, a renowned theoretical physicist, began to review the data pouring in from around the world. His involvement only added to the growing excitement, especially when he pointed out something that seemed unusual, something that would come to define this object as not just another piece of space debris. While the speed of the object was already astonishing, what truly intrigued scientists was its unusual chemistry. At first, they simply couldn't make sense of it. The object's velocity alone was enough to make astronomers sit up and take notice. The object was traveling at a staggering 137,000 miles per hour. To put that into perspective, this is 55 times faster than a bullet fired from an assault rifle. For comparison, even the fastest spacecraft ever launched, NASA's Parker Solar Probe, moves at just a fraction of this speed. 3I Atlas's speed means that it carries an incredible amount of energy equivalent to thousands of nuclear bombs. Despite the raw power behind it, the object's trajectory meant that Earth was safe. It was heading towards a close encounter with the sun, but thankfully its path would ensure that it remained clear of our planet. But it wasn't just the speed of 3I Atlas that perplexed scientists. It was the chemical composition that left them baffled. In August 2025, the James Webb Space Telescope, JWST, provided the first detailed spectrum of 3I Atlas. The results were unexpected. The object's emissions were dominated by carbon dioxide, CO2, with CO2 outpacing water vapor by an 8.1 ratio. To put this into context, most comets in our solar system release far more water than CO2, with even the most unusual comets generally not exceeding a 2.1 ratio. To have such a high CO2 to water ratio, 129 kiloliters of CO2 venting per second, compared to just 16 kilojoules of water, was extraordinary. This was the highest CO2 to water ratio ever recorded for a comet, and scientists could not explain it. Several theories were proposed. Some scientists speculated that 3I Atlas had formed in a distant star system beyond the CO2 ice line, a region where carbon dioxide can freeze while water remains a liquid. This would mean that the conditions in its home star system were vastly different from anything in our own solar system. Another possibility was that some sort of exotic radiation or processes had stripped away the water from the object, leaving CO2 to dominate. Yet, despite modeling these scenarios, the data did not fully explain what was happening. 3I Atlas's chemistry suggested an origin far removed from our own system, potentially from a region around a hotter, more massive star, or even from a time in the galaxy's history when the chemistry of stars and planets was still in the process of forming. This discovery alone raised many questions, but the surprises didn't stop there. As if this wasn't puzzling enough, astronomers at the Very Large Telescope, VLT, in Chile picked up even stranger data. They detected emissions of atomic nickel, but strangely, there was no iron. Normally, when comets from our solar system heat up, they release both nickel and iron together. But 3I Atlas was venting nearly 5 grams of nickel per second with no trace of iron, which is the most abundant heavy element in the universe. This anomaly further deepened the mystery surrounding the object. A number of theories were put forward to explain this. One possibility was that the nickel in 3I Atlas was locked in organometallic compounds, such as nickel tetracarbonyl, which break down at lower temperatures than iron. Another possibility was that over billions of years, cosmic rays had stripped iron from the surface of the object. But again, no explanation fully fits the observations. There was another oddity. This nickel emission appeared before cyanide gas, a chemical that is typically emitted from comets later in the process of outgassing. The timing of these emissions was completely out of sync with what scientists would expect, suggesting that something completely unfamiliar was going on. The unusual chemistry of 3I Atlas led to a flurry of internet speculation. The media, eager to capitalize on the excitement, seized upon the idea that the object could be an alien probe. Videos speculated that it might be a probe from another civilization, and social media exploded with theories, some of which were wildly inaccurate. Meanwhile, the real scientific research, which focused on the chemical anomalies, the missing iron, and the hyperbolic trajectory of the object, was drowned out by viral clickbait. Despite this, the scientific community remained focused on the object's unusual properties, recognizing that 3I Atlas was presenting a profound challenge to our understanding of comets and interstellar objects. As the data continued to flood in, the debate about 3I Atlas's true nature continued. But beyond the scientific intrigue, the question remained: what did this object mean for us? Was it just a random traveler from the depths of the universe? Or was it something more? While most astronomers lean towards the idea that it's a fluke, the improbability of its trajectory, especially the precision with which it passed near our solar system, keeps the debate alive. Some even suggested that it had been intentionally designed to pass through, though such an idea remains purely speculative. The global collaboration to study 3I Atlas was the culmination of years of work, and the data collected from this rare visitor has already begun to change the way we view the universe. What was once thought of as a closed and predictable system is now understood to be more open and full of surprises than we could have imagined. And as we continue to study 3I Atlas, one thing becomes clear. It's not just a rock from another star system. It's a message from the cosmos, telling us that there's so much more to discover, and that the universe is vast, unpredictable, and full of mysteries. The most striking feature of 3I Atlas was, without a doubt, its speed. As it raced through our solar system at 137,000 miles per hour, it was traveling far faster than any object we had encountered before. To give a sense of scale, this is roughly 55 times faster than a bullet fired from an assault rifle. For comparison, even NASA's fastest spacecraft, the Parker Solar Probe, which is designed to study the Sun, moves at a fraction of this speed. At its current velocity, 3I Atlas could travel from New York to Los Angeles in less than 2 minutes, an unimaginable speed when compared to anything on Earth. The raw energy associated with such speed is staggering, equivalent to the explosive power of thousands of nuclear bombs. Yet it wasn't just the speed of the object that captured the attention of scientists. It was the fact that this hyperbolic velocity meant that 3I Atlas was not bound by the Sun's gravitational field. Unlike most comets or asteroids that orbit our solar system, this object was not on a return trip. It was on a one-way journey, speeding through our solar system and continuing its journey into interstellar space. This fact alone made 3I Atlas a unique object of study, as it was only the third interstellar visitor to pass through our solar system. The first was Oumuamua in 2017, a cigar-shaped object that slipped through the solar system before scientists had a chance to study it in detail. The second was Boris, a comet detected in 2019, which exhibited unusual chemistry that baffled astronomers. Now, 3I Atlas, larger and faster than its predecessors, was sending shockwaves through the scientific community. As the object's path took it further into the solar system, astronomers began to turn their attention to its chemistry. This is where things became even stranger. In August 2025, the James Webb Space Telescope, JWST, provided the first full spectrum of 3I Atlas. The results were unexpected, to say the least. The object's emissions were dominated by carbon dioxide, CO2, a substance far more commonly associated with Earth's atmosphere than with the composition of comets. The CO2 was released in a ratio far higher than anything seen before in a comet, an 8:1 ratio of CO2 to water vapor. To put that into perspective, even the most unusual comets in our solar system typically release more water than CO2, with the highest ratio rarely exceeding 2.1. Here, however, the situation was completely different. The emission of 129 kiloliters of CO2 per second, compared to just 16 kiloliters of water, was a red flag for scientists. This was the highest CO2 to water ratio ever recorded in a comet. The implications of this were significant. For one, it suggested that 3I Atlas had formed in a star system where conditions were vastly different from our own. Some researchers proposed that the object had originated from a distant star system beyond the CO2 ice line, a region where temperatures are cold enough for carbon dioxide to freeze while water remains in its gaseous state. This would mean that 3I Atlas had formed in a completely different environment from the icy bodies we're used to studying in our own solar system. But even this theory didn't fully explain the object's unusual chemistry. Theories that suggested the object had undergone intense radiation or other exotic processes to strip away its water and leave CO2 behind also fell short of offering a complete explanation. The data gathered by the JWST led the team to one inescapable conclusion. 3I Atlas came from a region of the galaxy unlike anything we had seen before. It may have originated around a hotter, more massive star, or perhaps it formed during a time when the galaxy's chemical composition was still in the process of evolving. Either way, its chemistry was unlike anything seen in our solar system, challenging everything we thought we knew about the formation of interstellar objects. And just when scientists thought they had uncovered all the mysteries 3I Atlas had to offer, new data emerged that made everything even more perplexing. In July 2025, the Very Large Telescope in Chile detected something even more puzzling. Clear lines of atomic nickel were observed venting from the object, But curiously, there was no iron. In our solar system, nickel and iron are typically found together in cosmic bodies, often forged in supernovae, and released when comets heat up. However, in the case of 3I Atlas, there was no iron to be found, just nickel. This discovery further deepened the mystery. The object was venting nearly 5 grams of nickel per second, but no trace of iron was detected. This was highly unusual, as iron is the most abundant heavy element in the universe, and its absence raised even more questions about the object's origin. Theories began to emerge to explain this anomaly. One possibility was that the nickel in 3I Atlas was locked in organometallic compounds, such as nickel tetracarbonyl, which break down at lower temperatures than iron. Another theory suggested that cosmic rays had stripped iron from the object's surface over billions of years. However, these theories still didn't fully explain the absence of iron, leaving scientists grappling with a mystery that refused to be solved. Even more surprising was the timing of these emissions. Normally, nickel and cyanide gas are released in a specific sequence during a comet's outgassing process. But in the case of 3I Atlas, the nickel emissions appeared before cyanide gas was detected, completely flipping the usual order. This was yet another anomaly that defied expectations and suggested that something entirely new was happening. As if these chemical anomalies weren't enough, 3I Atlas also presented astronomers with an odd trajectory. The object's path took it within close proximity to several planets in our solar system, including Mars, Venus, and Jupiter. A team at Harvard calculated the odds of this happening to be incredibly low, just a 0.05% chance, or 1 in 20,000. These near misses were reminiscent of the gravity assist NASA uses for its space missions, such as the Voyager probes, which rely on slingshotting past planets to save fuel. This precise trajectory led some to speculate that 3I Atlas was not just a random traveler, but rather an object designed to observe multiple planets. Adding to the intrigue was the fact that 3I Atlas's closest approach to the Sun occurred behind it, hidden from Earth's view. This meant that scientists were unable to observe the object during its most active phase, further complicating the already challenging task of studying it. The question arose, was this a cosmic fluke, or was there something more to this object's path? In an effort to trace 3I Atlas's origins, scientists used the Gaia star catalog, which maps the movements of over 1 billion stars. The data indicated that 3I Atlas's trajectory had a steep inclination and an excess velocity that suggested it came from the thick disk of the Milky Way, an area known for containing stars up to 10 billion years old. This raised the possibility that 3I Atlas had been traveling for a very long time, perhaps as long as 7 billion years. Some researchers even suggested that the object had been ejected from a star system that no longer exists, making it a relic from the early days of the galaxy. This new evidence painted 3I Atlas not just as a random object, but as a time capsule, an ancient traveler that had journeyed through the galaxy for billions of years. The object's chemistry, speed, and trajectory all suggested that it had witnessed the rise and fall of stars long before our solar system came into being. In the brief months that astronomers had been able to observe it, they had glimpsed a piece of deep time, a window into the early days of the galaxy, before Earth had oceans and the sun had settled into middle age. As scientists continued to study 3I Atlas, they realized that its presence in our solar system was not just a curiosity, but a profound reminder of the vastness and complexity of the universe. The object's journey had begun before Earth had even formed, and the data collected from its brief passage through our cosmic neighborhood had already changed the way we viewed the universe. It was no longer just a rock from another star system. It was a message from the cosmos, telling us that there is still so much we don't understand. In the end, 3I Atlas had forced us to confront how little we truly know about the universe and our place in it. Whether it was a random traveler or something more, its brief visit had shown us that the galaxy is full of surprises, and we are only just beginning to understand the complexity of the cosmos.